Hi guys, who are there? Uh, can active people try to? I need water. Maybe face wash. I don't know. Whoever is active, can they try to chat? Can you guys hear me? I'm getting a notification. Let me check out what is that. Watch live now. Codeforces from post contest discussion. They are smart. Nice that is. We need five viewers to start. I think I haven't seen the contest questions yet because I was out, I guess. Now I will try to enter the contest. See, it's not violet. Okay, I have to share the screen, right? Am I sharing the screen? Yeah, I'm sharing the screen. So yeah, so this is not violet yet. It's not purple. It's like bluish. If you guys know. So we need five viewers at least, or else I'm not starting. And the viewers, if the viewers are not commenting, that's bad. Yeah, we have comments now. We have active chat now. You guys can hear me properly, right? Can you guys hear me properly? I'll start. So I haven't yet seen the problems of division 3, although they are easy. So I will try to read the problems now. If you guys and try to solve them quicker too, okay? Because solving quicker is important, right? In contests. Till now I have only focused mainly on solving the problem, but now I'll try to solve it quicker too, okay? Because solving quick is important, right? Okay, we have five viewers, so I'm trying to start. All the viewers, I want them to be active. Okay. So type something in the chat. Don't be so lame, okay? So I'm starting to read the problems. What should I read first? So we have E easier than D somehow. That would have fucked up some people's contest, right? And then people cannot read F at all because if D itself had made a problem and E itself had made some other problem, people would have gotten scared with F, a lot scared with F. But 1600 solves says it's easy. 69 solves says that it may not be that easy somehow, right? So what should I go first? What should I go first? Oh, we have 10 viewers. That's a lot. Guys, give me a question. So I'll try to read some problem, okay? Maybe both D and E. And C too. C sounds nicer problem, right? So I'll try to read C. Make it equal. Given two multisets S and T of size and a position integer K, you may perform 1 minute. I might have to do something. I might have to don't check all of these things. Okay. I fuck. I don't like editing things. Please don't go and check whatever I have. Okay, please don't do that, people. 1043 div 3. Is that it? If I edit, live chat will be lost. So I have a trade-off between choosing my privacy or uh, preserving the chat. So do we have viewers? 10 viewers is a lot, guys. Okay, I will go for C and then A and then E maybe. Let me read C. Let's read C. Like let's try to read the problem C. So most of the time, guys, also like the video. Don't be lame again. I'm telling again. Be active. So given two multisets S and T of size n and a positive integer k, you may perform the following operations any number of times. Select an element x in S and remove one occurrence of x in S, then insert x plus k into S or insert modulus of x minus k into S. Determine if it is possible to make S equal to t. Damn, this sounds scary. uh, this sounds like a bit difficult problem, right? I mean, it can be difficult. This problem, until we try to find some facts in it, we cannot say if it's easy or difficult because uh, overall structure of the problem is an operation is there, and then we can do this or that, and then it's like if you can make S and T equal or not. So unless we make some observations, we don't know if it's an easy problem or a difficult problem in general, right? Because it's in division 3C, it's an easier problem. Obviously, there is some small fact and then it's done. But I'm telling in general, this can be div 1 C2. We will never know if it is just a bit somehow computationally different. right? So we have to try to make some observations. That's what we have to do on operation and then on what they have asked. So if problem statement is we have to multiset SNT of size n, and then operation is take an element in S, replace it with either x plus k or modulus of x minus k. These are the things, right, we can do. This is what we can do. So if you observe one thing that we can obviously say about the operation, it's always uh, beneficial to see what's not changing, because people will tell you topic names, but they don't tell you things like it's good to see for invariance, or if it's a minimization problem, it's good to see for lower bounds. These are the ideas that we will use repeatedly, like, and then maybe trying to see parity. Sometimes these ideas we see repeatedly, and problem depends on exactly these things. It doesn't depend on topics. There are no topics. These are just some small basic ideas. So if you try to because whenever there is an operation, invariants are important. What is an invariant? Something that doesn't change after you apply an operation is an invariant. uh, whenever there are operations, we can try to see invariance, or we can try to see something that doesn't change much. Sometimes if you see something that doesn't change much, we can bound up number of operations by that if it's a minimization problem. But here we can see an obvious invariant, right? Because we can do many number of operations, invariants are important because that means we can do any number of operations, right? Fuck. Also, uh, it's also it also helps to see if the operation is reversible at many times. Okay, see, you guys may think I'm unnecessarily complicating the problem, but what I want to do is teach you guys techniques in a more general way, which is not presented in others, probably other Indian streams at least, because they would not give that much effort into how to solve the problem, right? It's not about solving the problem, but how to exactly solve. So let's see if this is an uh, a- reversible operation or not. Okay, if you have x, let's say greater than k, uh, uh, okay, if you have x and then you made it x plus k, now you can again come back by removing k. If you apply this, if you apply uh, sorry, I mean, I'm making it complicated, but if you apply minus k thing, you can immediately come back to x. X is always positive, right? So we are never going to negative. And if you have applied modulus of x minus k, if x greater than k, you can come back. If x is less than or equals to k, you can again come back. If you apply again the same thing, because 0 to k, let's say x is less than or equals to 0 and k, if you apply x modulus of x minus k twice, x minus k is nothing but k minus x, right? If you apply that twice, you're getting x. So the operation is reversible, is one small thing you can say. And I will go a bit deeper for you people, okay? uh, Whenever the operation is reversible, okay, that splits things into equivalence classes. Okay, how or why? Let's see. What does you guys will probably know equivalence class relations, right? We want it to be reflexive, okay, and then we want it to be this should be present in the set. Like there should be a relation between a comma a. There should be a relation between symmetric. A comma b implies b comma a. And one more thing is a comma b. If a comma b implies, if a comma b comma c, then a comma c. These three properties. Whenever something is reversible, sorry, whenever something is equivalent, if a relation is equivalent, then the whole set, let's say this is set A and relation R, the whole set can be splitted into equivalence classes. Okay, now because I'm complicating things, I want to know if you guys understood this thing well or not. I will give an example about these equivalence classes, but this is some logical thing you can do. I mean, s- seeing whole is difficult, but if you can just see the operation is reversible, you can have that the whole set can be split into disjoint. I will explain this a bit better right now. Okay, so let's say how difficult is it till here. Okay, guys, respond to me. Okay, what you people are doing? So let me give an example for this equivalence class and the disjoint splits. Okay, I will give an example. So if you see the relation in a graph, let's say A is reachable from B, means A comma B belongs to R, let's say. R is the relation, okay? R is the order pairs, set of order pairs is a relation, okay? So is this relation equivalence? Okay, let's try to check this if this is equivalence. A comma A is reachable. Two, if A comma B is reachable, means there is a path from A to B, means there is also a path from B to A. If it's undirected graph, you guys can see directed graph fails right here, because if there is a path from A to B, you cannot guarantee that there is a path from B to A. And that's the reason why we don't have an equivalence relation like this in directed graphs. In undirected graphs we have. And let's check the third one. If A comma B and B comma C, then A comma C. True, right? If you can reach from A to B and then from B to C, you can reach from A to C. So this relation of reachability is equivalent. Equivalent. So what does that mean? Means there are equivalent classes. So now do you guys wonder what are these equivalence classes? These are connected components. So now we can say using this equivalence class, this is when say, using this statement that whenever you see this, they will be split into disjoint things, means uh, they are like equivalence classes. These are connected components with equivalence classes. So here each connected component is an equivalence class. Everything inside that are in relation with each other, and none of them are relation with the outside thing. So they will be split into equivalence classes. If you take modulo m 0, 1, 2 up to so on m minus 1 are equivalence classes among all integers, let's say. If two things remain the same, let's say they are an equivalence class. So what does this mean is, if they if you are given something and if there is an equivalence relation, that means that means it's not alone, like it has its equivalence class and all of them are same, all of them are almost same, they are all equivalent kind of thing under that relation. So now if you see, if our operation is reversible, that means if some state A and B, uh, let's say A comma B is in relation if from A state A, you can go to state B. Okay. So this says whenever it is reversible, it is equivalence class. It splits the all possible states into equivalence classes. It splits everything into equivalence classes. Do you guys get what I mean? Whenever it's reversible, because reversible means if A can go from A to B, there is a way to go from B to A2. Because reversible says that. So this means all you have to do here is if set S, what the fuck is this? If set S and set T are in same class or not. I mean, the problem may be complicated, but the fact that the operation is reversible just simplifies the problem a lot. Now we need not worry about weird observations that you're gonna make on S and T. Do you guys see how I'm showing you how to approach a problem? I'm not telling you to randomly try to find some observations, right? But the most basic observation that we can make on the operation is here that it's reversible. That should be the first operation we can make. I know it's an easy problem. We can somehow get some kind of solution and all. But uh, because it's an easy problem, we can somehow guess that. But then the first observation you gotta be making here is that the operation is reversible. Okay. And then is there an invariant? If you do x plus k or x minus k, it doesn't change the remainder with k, right? Doesn't change, but it changes when you do k minus x, right? So it's like also k and k minus x are equivalent. So k and k minus x are equivalent. Let's say it's something like that. So this simplifies everything a lot because there is an equal. So okay, I will give you one more statement. And whenever there is an equivalence class, okay, we can look at some corner case in that class. We can look at some corner case in that class. So we have two sets here, S and T. If you can somehow make S into some corner case and also make T into that unique corner case, and then compare if they both are same or not, we are done. So what can be a good corner case here? Just taking remainder with K, right? Making everything less than K. It seems like a corner case, right? Because the operation is reversible now, we need not worry. Make everything less than K, okay? Make everything less than K. So let's try to see some corner case in uh, A equivalence class. If you see this, we can always make S elements less than K. So everything is just remainder K. Take remainder K with everything. Okay. Now we have zeros, ones, twos, up to so on. But K minus ones also. But we know ones and K minus ones are equal. In some way they are equivalent. Because a 1 can be converted into a k minus 1 using just one operation, which is modulus of k minus x. So so this corner case, so even make all these two ones. Let's say our corner case is zeros, ones, 2s, up to so on, k by 2, k by 2s, seal of k by 2s. Okay, what does this says? We will also make this as into this. This corner case in our equivalence class must be unique, right? This cannot be this must be unique because only ones and k minus ones can differ, and then all of them can only change among themselves. So this must be unique. So if you just make this for both s comma t, if they are equal, then answer is yes, else answer is no. That's it. So if anyone has tried the problem and then they have thought it's like unapproachable to me, I know, see, the ideas that I have used, we can use them in 2800 to 2700 too, right? Like it's not It's not that I'm overkilling a div 3 problem. C, C. This would work probably. So 1 and 2 should be no, right? Okay. K is 3. Okay, 1 and 2 are same because 3 minus 1 is 2. Is this clear till here? Reminder is not an invariant. Invariant is something that doesn't change. Is this solution clear to people? Also like the video, okay? Tell me if there is a problem, because first till here it's fine. If you come here we can go back. Be clear, if you can come here we can go back. Now the problem is ones and k minus ones can be changed interchangeably. They won't affect twos, but ones and k minus ones can be changed effectively. So frequency of zeros, ones or k minus ones, twos or k minus twos, up to so on, is an invariant. If you try to see first them as reminder classes, okay, because only reminder matters, and then if you try to see what is an invariant, because k minus x is also possible, reminder is no longer an invariant, but one number of ones and number of k minus ones, this becomes an invariant. Frequency of this is an invariant. Frequency of this is an invariant. Frequency, all these frequencies are invariant. So invariant is what, something that doesn't change. So once you find that invariant, these are all the invariants. Because it's an invariant, that should be same for S and T. And if it is same, you can come to this and then go back to T. How equivalence class is again helping, I'm just telling you logically how does it help. So all we have to do is count of reminder zeros, and then count of reminder ones plus reminder k minus ones, and then count of reminder twos up to so on. We have to go to the seal of k by 2, and then we just have to check, because this is an invariant, if it's same for S and T or not. Is that, does that make it clear? Invariant, something that doesn't change. 2 years ago, 3 years ago, I guess, I got internship offers from Rubrik, AlphaGrep, APT, NK Securities. But then I chose APT, and then things didn't go well. Now I'm just working at Apple. And then I'm not trying too much for HFTs. Somehow I lost interest. I should have, maybe, I should still maybe, but somehow I lost interest in them. Not just interest, maybe I'm not applying very often, or I'm fine where I am. It's complex. So is this clear? Is this an invariant? Do you guys see how this is a topic you never heard before? How you were fooled by topic names, but how you never got to learn equivalence classes, how you never got to learn invariance, how you never got to learn reversible operations. These are the topics that repeat every time, and not the topics you see on tags. Okay, because those are somehow misleading. These are the ideas that repeat in any difficult problem. Maybe even some, there are some 3100s with just looking at invariant. Once you see that this is the invariant, then you're done. Problems are just like that. This is an easy invariant because it's so fucking obvious that 1 can become k minus 1, k minus 1 can become 1. So sub, but 1 cannot become any other, k minus 1 cannot become any other. So their constant sum is equal. That's very obvious, right? Modulus of x minus k gives that very easily, because modulus of x minus k is, yeah, k minus x, right? When x less than k, it's k minus x. So this is an invariant. So it's all about just finding this thing now. Okay. So how easy the code will now be. I will maintain frequencies of zeros, ones, k minus ones, right? So how will I do that? How simple code can be, just see that. First I'm taking reminder, okay? And then I can even make it like minimum of x comma k minus x, okay? So now I have frequencies of 1 and k minus 1, 2 and k minus 2 up to so on. Do the same for t. Now just check. See people, this is premium content because there is no CP Indian YouTuber that's explaining you equivalence classes, that's explaining you reversible operations. Many of you might be hearing these things first time. That's explaining you invariance, that's showing you that there is an invariant in this problem, which is frequencies of zeros plus frequencies of zeros of ones one plus frequencies of two, k minus one. This whole set, it's an invariant. That's why I'm checking if the whole fucking set is equal or not, because for the both f and s, if they both are equal, you can come down to that, you can go back to t, because it's an equivalence class. If they both are not equal, there's no way you can do that, because they must be equal, because it's an invariant. This may be wrong. If it's wrong, I have this issue. I'm using some C++11 or something that it says this thing that I cannot do this zero thing. And then I want to become grandmaster. I can't even fix this compilation issue somehow. Okay, it's pretty much a lot to do on this easy problem, but let's see if it passes. How much time did I spend on such an easy problem? Some people who have solved C immediately might be wondering, he's doing too much on an easy problem, but I don't care, I guess. I see. I see. Wait a minute. What do I not see? It's correct, right? So I don't see anything yet. I thought like zero becomes k, but then it doesn't. Let me check. If k can be too big. For k can be too big here. Now don't change the topic to maps. It's not a topic, okay? It's not a topic. So now we have to check if these two maps are same or not. How do we do that? Fuck, how do we do that? For I don't know how to traverse a map. I'm getting caught. Is it like this? Count of v equals to f dot second if cv naught equals to frequency of t comma v. See, again I will use logic that if it is equal for everything, that means there cannot be anything else in t, because so total sum is n, right? So there cannot be anything else in t. Normally we have to check. This checks if this is a subset of this, right? But then total sum is same in both. Total sum is n, because I need not check if everything in t is in s or not. I hope you guys are getting the logic what I'm trying to say. Damn, I know syntax. We have to say constraints too. K is 10 power 9, you cannot use that big array, okay? So it got accepted. I should have joined rubric, I guess, maybe. Then I might have had a PPO. I could have enjoyed college. I could have be earning more right now. But it is what it is, I guess. I don't feel too much on that. I have to become grandmaster, I guess, first. So now let's try D and E. Or someone asked me E. Long back I have seen someone asking me E. Saurav Kumar asked me E. But then we have A too. Kailash Chaudhary is repeatedly asking A. And then he's asking me how I'm not frustrated. Do you want A, Kailash? So let me read A very quick, okay? In divergent universe, the lever iterates itself given to arrays A and B of length n. What the fuck does that mean? In each iteration, the lever will do the following. Choose a random. This is also, see, all these problems look hard, but then they won't be hard. That's what problem solving or core forces is all about. When it looks hard, when it appears hard, you still have to try. And you would do that on div 3a because you know it's easy. But then you think the same on div 3e or f or g because you think it's much more difficult. That eliminating that fear is half the step. It's really much more important than learning topics or seeing streams of other people. I would never watch someone else's stream. I'm just joking. I want viewers stay and view sometimes because it's premium content, right? Mm, the level iterates itself given you guys should try on your own a lot more than watching streams. You guys should try a lot more on your own. You have to keep trying a lot, not going disappointed on some simple things. Choose a random I such that AI greater than BI, then decrease AI by 1. If there doesn't exist such I, ignore this step. So we must do this if it exists. Choose a random integer. If it doesn't exist, then ignore this step. After each iteration, the lever will check if step 1 is ignored, and if so, it will end its iteration. Yeah, if this is ignored, we will end the step or what? You're given to arrays, find the number of iterations that the lever does. It can be shown the number. This number is fixed over all possibilities of random indices that the lever can choose for each step. So this seems like a nice problem somehow, because they gave us something that lever can do by doing randomly, and then still they are telling the number is fixed. Okay, so we just have to find something about the operations again. We have to say something about this. So if AI greater than BI, it will reduce AI buffer, right? Can it not go to infinite? Maybe it won't because they're asking to output that answer, right? So whenever something is more than the other, we can do an operation. And once once everything becomes equal, only then we cannot do first operation, right? They are telling when you cannot do first, uh, stop the iteration. If you cannot do first step, stop the iteration. So we'll go until after an iteration, if everything is equal or not. We go till then. If you see AI and BI, oh, what the fuck? So AI and BI are two arrays. I is just the index. I thought it's like for all pairs, but it's not. It's even simpler. I thought it's like for all pairs, we are selecting two pairs randomly and then we are doing this, I thought. But it's not. Simple. Like this I. Choose a random index I if and then so BI doesn't change. Only AI changes. Things are simple here. BI doesn't change. AI changes. If AI is above, after each time it keeps coming down. If AI is below, after each time it keeps coming up, and once it's equal, you cannot do any number of any operations, right? And you can either do top thing or you can either do below thing, right? But then The thing is, it seems a bit confusing, right? Because we can choose randomly anything. But once you, in one, let's say there are some things where AI is above BI, some things with AI is less than BI. These are the two cases, right? You choose this, you reduce that. You choose that, you reduce this. So, as long as we have elements which are AI greater than BI, we keep choosing 1, 1, 1. So, we have two types of elements, okay? Two types of indices. One with AI greater than BI, two with BI greater than AI. Let's say this count be CG. This count be CL because AI is lesser. So we keep doing this or this or this or this. And these things exist until SG, let's say, because SG is sum of AI minus BI. And these things can exist till SL, number of operations. So we stop once the above things are done. We stop once these are finished, right? We don't care about these things, I think, right? We stop once these are finished. So here 7 minus 5 is 2. So the answer is 3 because we will come once again to see if this exists or not. Let's see here. All of them are equal. So answer is 1. Let's see here. 9 plus 1, 10. Let's see here. 4 minus 1, 3. 4 minus 1, 3. So answer is 6 plus 1, 7. So only this thing matters. This doesn't matter. This doesn't contribute to number of iterations. So answer is just this. Answer is just this. Okay. They are just trying to scare us. Did I not explain this well? If I think about it, I think I did because as there are only two types of indices. Because once AI becomes BI, it is useless. And how many iterations can that go? Till AI minus BI iterations, right? And then we have one iteration where we cannot find this, so plus one. Only these things matter. The other thing is just to confuse you people. The final iteration, okay, where we no longer can do anything. So now I will try E next because E is easier than D and I'm scared of D, so I'll try E. Okay. What problem should I try next? I should be quicker because yeah, people will solve in 1 minute, right? Not this long. Motherfucker, red. I have done C already. Okay. I've done C already. Watch it tomorrow. Okay. I will do E and F. Rohan telling E is a standard problem. I will do E, D, and F. E, F, and D. Okay. I'll try to be quick. It's just 39 minutes. I'll try to do uh, both E and F. I think I'll do F too. But people, don't get scared of F. Okay. If you're someone who cannot solve E or D, still you need not get scared of F. Right? Still you need not get scared of F because what's the point in getting scared? I mean, I am doing streams because I want to show you people how problems can be solved, right? So that's something you have to try. You have to try difficult ones and see if they're actually difficult or not because they appear difficult. They may not be actually difficult, right? So let's do F. All the newbies here, don't drop. I want you people to try problems that you're scared of. because that's what problem solving is. It's learning about how to try something that when it feels like you cannot solve it, there are no topics. This skill is what you have to master. So let's try to read this problem, okay? And then I'll go to E for sure. I won't take too long in F, okay? I'll try to be quicker. In general, in streams, I generally go slow, but this time I'll try to be quick, okay? Yuri is given two binary strings. So there are just two binary strings. What's there to get scared of binary strings? There are no topics, both of which are of length n. Two strings dynamically. Did viewers drop? No, they haven't. Yeah. So guys, please stay, please try, please focus. Okay, they have dropped from 25 to 21, but uh, like the two strings dynamically define an n cross n grid. So there are two strings and then they define a grid, it seems. Let I comma j denote the cell in the ith row and the jth row. Let it's that the initial value of the cell is ai XOR bj. So we have binary string. The cell has both of their XOR. Okay, simple. It's not too complex. XOR is not too complex. One means zero, zero one means one means zero. So we have a grid, but it's very dependent on just 2n information. The information in the whole n square grid is just of 2n bits is the information in that whole n square array. Okay. Yuri's journey always starts from cell 1 comma 1. From a cell I comma j, she can only move down or right. Okay, down or right. Her journey is possible if there exists a valid path such that all cells on the path, including 1 comma 1, have a value 0. So this seems doable, right? It's not some weird topic. What topic can help? Persistent segment is help. Does that help here? In no fucking way it can help. It's telling a simple problem. If there is a path with all zeros, you can go. Don't get scared of XOR. XOR is just 0 1 1 1 0 1 1 0 0 0 0. It cannot get more complicated than that, right? That's what it is. That's what it all is. It cannot get complicated than that. Before her departure, she can do the following operation any number of times. So now she can do an operation. Again, we have operations, and then you guys cannot be scared of operations, right? Any number of times. That's again a nicer problem. Choose one index and flip the value of either AI or BI. The grid will also change accordingly. But then we can once choose AI and then we can once choose next time we can choose BI. That means we can change everything. Is that the understanding? Let f of x comma y denote the minimum number of minimum required operations so that okay, this makes sense. I think we can change any bit. We can change any bit. This doesn't make much difference that choose an index. You can change any one bit. So this will flip a row, this will flip a column. That's also obvious, right? Because AI will flip a whole row, BI will flip a whole column. F of x comma y denote the minimum required operation so that Yuri can make her journey to the cell x comma y. You must determine the sum of f of x comma y over all. See, it's a good problem, right? If you can determine over all, that means you are simplifying things. You will simplify things. If you have to compute this, believe in golden rules. If there is a simple solution and there is a simple proof and then there is a simple implementation, this problem must be solved logically. Note that each of these n square cases is independent, meaning you need to assume the grid is in its original state in each case. See, we have a grid and then they're asking us to do from 1 comma 1 minimum number of operations so that it's possible to go from 1 comma 1 to x comma y, and then we have to sum this over all things. Isn't this a good problem for you people to get scared? You have to somehow simplify. What is this? I'll make it simple. we can work on this thing. We must simplify what is this minimum number of operations, so that you guys have to believe in golden rules, that if you believe in golden rules, we know what should be done. We must simplify this minimum number of operations, and then we can also think of this question. They told all of this should be zero, like there should be a zero path. There should be a path that has all zeros, but what does that mean? How can we solve that? Sure, last guy, I hope you're not the last guy in this stream. Bye. Because the problem asks us to do it in O of n, that must be done in O of n. You simplify this, if you simplify this and then it turned out that the minimum number of operations is 0, then you can do it in O of 1, right? 0 times n square is 0. So once you simplify, it can be possible to do in O of n, okay? Do you get what I mean? Let's say the answer is 0. 0 times n square can be done in O of 1, right? So if it is simplified, then you can do summations quicker. Does that answer you? I will quickly do F and then I'll go for D. I will try to, let's try to think about it now. Okay. Now we want a path that has all zeros from here to x comma x. What is the minimum number of operations you must do? If there is a path already, then you can reach. Okay. So what? So we have to comment on this thing. When can we reach? When can we reach from x comma y to 1 comma 1? When can we from 1 comma 1 to x comma y? When can we do this? 1 comma 1 must be 0, right? Means a of 1 equals to b of 1. This must happen. And then so there should be a path from 1 comma 1 to x comma y, with a of I being a of let's say path b I comma j in between. All of this should have a of I equals to b of j. This is the rule, right? So this path should be there. Okay. And in one operation, what you can do, you can think, you people also think a bit. You can flip a row or a column. We have to think for some time, we have to try for some time, so we will find something that's simple, and then we can use that. So if there is a path with all zeros from here to here, then we can reach that. And when there will not be a path, we have to think for some time. So so let's see this simple thing. Okay, let's look at some path. We're looking at some path. Can some path always be made? Can some path always be made zeros? We can make it zeros, but sometimes we need two operations. So let's look at some path. Okay, some path will start from here, go straight, go down. I'm again complicating things instead of trying to look for something. Let's say there is some path. What would be the minimum number of operations to do on this path? Can be something we can try to think on. But it's a bit complex. We need not think about that, but that's something at least we can try to think on. Let's try to think about this problem sometime. Okay. Let's try to solve it. I know it's boring, but you guys should try. I will do E. I understand. I'll try F for some time and then I'll get back to D immediately. Okay. Let's also you people try F now because it won't be too difficult. It says it's an easy problem. So let's try to see this path. If you see some path, it's not that easy to make all of them as zeros because let's say you have a row in your path. You have a row. You can change the whole row, or you can change one thing in that row. That doesn't seem so easy, right? Let's say if we look at 1 comma x for simplicity, let's look at this from 1 comma 1 to 1 comma x. The path is unique, right? And what's the answer for this? You can flip whole or you have to flip individually, right? So you can flip all of them in one operation. Doing that twice is useless. Doing any row twice is useless. Doing any column twice is useless, right? Doing any row twice, doing any column twice is useless. We can write those things to do. So if we use x rows and y columns, what's their result? What's the result? These x rows have been changed, these y columns have been changed. The result is, you can see the pattern, right? What's the result? The result is obvious, right? Uh, you're changing x rows and then y columns. Is there no white color? This will be changed twice, 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 this will be changed twice. Try people, try for some time. I'll try to do D and F and E2. So this is an obvious thing we can say. Flipping something twice is useless. And then if you're finally flipping just x things and just y things, then this would be the thing. Right. For this, the answer is minimum of count of zeros and count of ones plus one. Because this says make all ones as zeros. If there are one, make them 0, 0, 0, because we are looking at only first row. Okay, we make them as zeros. This says we use one row and then we make the previous zeros as ones. Okay, so it's like minimum x plus y. We have to choose some x, some y, and then the x plus y should be minimum so that we have a zero path from here to there. Again, it's still looking a bit complex. We have to find something that simplifies the problem. We have to find something that simplifies the problem. Okay, it wouldn't be that difficult because we have to sum them over all x comma y easily. So this is answer for one row, but how can this be simplified if okay, let me try. I'm just trying to see if I can make some point. Okay, it seems like we can't do anything, but this is something we can say. But this doesn't look too simple, right? So we can change all this, but these things will remain same. Is what it means. Whatever the string is, what I mean is, if you are doing a change, this is what gonna happen. If you choose x, y, and x, these things and y those things, that's what will happen. Okay, let me go for E or D because D was most asked, right? E is most asked. D is also asked. Let me read E and D too because we cannot get stuck on this problem. Even if it's a contest, I will come back to D or E. Okay, so let's try to read D. Kagari is preparing to achieve a tree, and she knows the cost of doing so will depend on its diameter. To keep the expense down, her goal is to shrink the diameter as much as possible first. She can. I don't know who devised this contest, but they all look scary. Or maybe I am drunk a bit. Down. Her goal is to shrink the diameter as much as possible. She can perform the following operation on the tree. So we have to shrink the diameter. It seems okay. We have a tree. Choose two vertices S and T. We can do an operation. Let a sequence of the vertices on the simple path from S to T be this. But okay, we are removing this and then we are attaching the first vertex. The first vertex V0. This is what we do. It seems okay. It can be shown that the graph is still a tree after this operation. Okay, that makes sense because it's still connected. It's still connected. It still doesn't have number of edges is same. If it is connected and if the number of edges is n minus 1, it's a tree. Help her determine the minimum number of operations to achieve the minimal diameter. But what is the minimal diameter is the first question. What's the minimal diameter? We want to achieve this thing in minimum number of moves. So what is it? Let's take some vertex 1. If you keep doing things with 1, minimum diameter is 2. It must be 2, right? 1, 2, 1, 3, 2, 4. Choose 1. Operate always, it ends up like this, right? Let's say you choose 1. Let's say you choose 1 comma 4. It ends up like this. So that's simple. First question is simple. You have to make minimum diameter as 2. Now there is a center, right? So the structure is, there is a vertex S and everything else is attached to this. So did you people come till here? Till here it seems direct, right? Hi guys, can you see me? I see Ayush have asked me that in comments too, but it's not about DSU on tree, Ayush. It's just DSU. But then you use DSU while being on tree. You want to merge subtrees, so you do it like that. So that's the first observation. If you guys got scared, even before making such a first observation, I'll try to help you later, Ayush. But yeah, if you guys are scared, you might not even make that observation. So now what to do is fixed. You must probably brute force over all possible s, right? You must probably brute force over all possible s. Let's try to look at some s. Okay, that's what we can do. If you look at one s, let's root s. We should find minimum number of moves to make everything get attached to s. This seems very direct, right? Like it's very constrained. Everything must come to s now, is what we want. Let's say if you fix that center, everything must come to s, is what we want. And what we do is choosing paths, right? If you look at leaves here, because we are using path, a path comes to s. Leaves are the farthest things, right? Leaves are the farthest things, right? They will only come when you choose s comma leaf. If you guys try to understand what I'm doing here, this is a lower bound. I know I'm complicating things, but if you guys try to observe how all problems are same problems, if you guys try to observe how all problems are same problems, like how I have mentioned upper bounds here, that, sorry, lower bound. Minimization problems has lower bounds. Here, this is a lower bound. Why is this a lower bound? Because if leaf must get attached to s, you you cannot attach leaf unless you do such a thing like s comma leaf. Unless you do this, you cannot do. This gives us a lower bound, which is you must do greater than or equals to sum of leaves, because leaves will only get attached if you do s comma leaf. So you want s comma leaf 1, you must have s comma leaf 2, you must have s comma leaf 3, you must have all of those things. But maybe there is another way. There is no other way. There is no other way, right? There is no other way. You may think maybe doing something and then coming here uh may reduce number of leaves, you may think, but still, but still after an operation a leaf remains a leaf. leaf. So whatever leaf you take, after an operation it remains a leaf. If it's not getting attached to S, that doesn't help at all, right? We have to think about this. Let's say after an operation, number of leaves becomes -2, then we cannot still apply this logic probably. But after an operation, a leaf remains a leaf, and then again it must come and attach it to S when S comma leaf happens. Otherwise, it cannot come and get attached to S. Leaves will only get attached to S when S comma leaf happens. This is true. So that gives us a lower bound. And then if you have a good enough lower bound, that will be minimum. Because when you solve a minimization problem, you also prove that. That's the minimum, because proofs are simple. Sorry, solutions are simple, proofs are simple, implementations are simple. That means in most of the minimization problems, you can actually look for lower bounds. You can actually look for what must be done. Right? You don't try to randomly do things and hope that what you do, you have to prove that what you're doing is optimal. So what's the way? Looking for must be done things. For minimization problems, you must look for must be done things, not trying to get some random procedure. So this solves the problem, right? It's just number of leaves. Because now you see this is a good enough bound. If every leaf comes to S, everything in between also came to S, right? So it's just answer is just number of leaves. Answer is just number of leaves. Okay. I mean, if something had many leaves already, they need not come to S again, right? They are already attached to S. So answer is number of leaves when S is rooted minus number of leaves attached to S. This is not that complicated, right? Number of leaves attached to S when S is rooted minus number of this. This is simple. We just want number of leaves count for all S. This is simple. And what about this? What about this number of leaves when S is rooted? Total leaves minus is S a leaf? Because if S is a leaf, number of leaves when S is rooted will be, not considering this one, right? All the remaining leaves still exist. They cannot disappear. Leaves or leaves, whatever you do. You root S, only that will become leaf. So it's that simple. Brute forcing on S is not difficult now, right? But once you brute force on S, you will try to find number of leaves when S is rooted, which is total leaves minus S is a leaf. And then we'll just subtract number of leaves, attach it to S. We don't even need a DFS here. Is that clear, people? D. Such thing. C. Yeah. So it's brute force. It's not that difficult. See, Rohan, how you got robbed. How you got robbed of D, which you could have been solved. Right. So don't be scared. I'm telling you, it's not just some positive shit that I'm telling. It's really important. Not being scared is half the problem. So now I'll try to code this. Because see, once you make solution clear, it's that simple. I need not even do a DFS. But see, anyone can solve the problem. But how I am using lower bounds is what I am telling you. Because this is the same way to solve a 3500 problem too. Because minimum, you must prove you don't. You must prove And for minimization problems to prove, it's always about lower bounds, because the fact that you are proving at least this is minimum, that means at least that must be done. Because that means there is nothing smaller. If you're proving, you're also proving that. That means you're also showing that that's a lower bound. So minimization problems, if proofs are simple, implies and implies says that you are finding a lower bound. So don't complain on topics. Learn these things. Think and learn these things. I came up with all this on my own, right? Like that minimization problems have lower bounds and all these things. Like I didn't read them somewhere, obviously, because I observed, like that's how I believed in these things, and then we can observe those other things. I haven't believed. I want to believe, because in contests I mess up. I cannot perform well. What happened? So I will try to count number of leaves on each node. Okay, number of leaves on each node. Okay. We have number of leaves on each node, and leaves will only exist on some node, right? So count of total leaves is just nothing but count of leaves on all nodes, because a leaf cannot exist on two leaves, two different vertices. Every leaf exists on some vertex. So count of all leaves on, so this will be equal to total number of leaves. Now again we are brute forcing on S. So one fucking obvious answer is total number of leaves minus 1 2, because take that leaf, everything else minus 1. This can be a total obvious upper bound. Not upper bound, like, yeah, this is an upper bound, yeah. See, we want to find lower bounds, but then in implementations we just initialize to an upper bound, because initialization doesn't matter, right? It doesn't matter. It's just for it's just for implementation purpose. It doesn't matter. You can even give 1E18 because it doesn't matter. So now what? Total number of leaves minus is S a leaf, minus these are leaves when S is rooted, right? Minus number of leaves attached to S, which is C of S. So does this involve topics? There's not even DSU in this. That's why it was given at D. But then we all know the problems are not difficult because they are difficult, but because they scare us. She accepted it seems. Fuck, I took a lot of time, but not between these two, I think. Because I've tried F in between. Hi Vedant. So how's it people till here? Is D fine? Someone is asking me to go from scratch. Is nice here? Nice, are you there? I'll get some water. Please stay. What the fuck is school days? I'm scared now. So guys, uh, see, this problem is easy, but I'm showing you how I am using proofs. How I am using simple fact that S and leaf must get attached. But after an operation, a leaf will remain a leaf. So, and a leaf will get attached to S only if you do S comma leaf. How I am proving very clearly, see, I mean, it makes sense that, okay, choosing leaves is the best one. It makes sense. I get it. It's obvious. But how I am proving it to very well that it's a lower bound. It must be done because, I mean, it's too simple, but I get it. I like to prove because the thing is, you can question, right? See, S is there. Choosing leaf seems the best, but then what if choosing something else reduces the leaves, and then choosing that would be better? What if that? So, getting to the solution without doing all the facts right, without doing all the steps right, will make you solve easy problems like D, this one. But the same problem, if it had something tricky in between, it will be plus 1000 rating or something, really. 1500 would be 2500 because you have to follow the steps clearly. You have to prove it actually. So the difference between someone who can solve uh, 2600s or 2700s and someone who cannot solve them really 26, because even at 23 level we don't need very good proofs. I think I cannot solve 26 in contest, but I can solve in practice. But what I have seen is, if you can do proofs, you can solve them easily at even higher level. I think at any level it's the same thing. At any level it's the same. Okay, this is an easy problem. Someone wants me to read H2, uh, but I'm getting stuck at F itself, right? F itself, right? So let me try E, and then I'll skip B. I will go for G and H. Okay, let's see how difficult can they be. So I think E has been solved by many people, right? So let me read H once. I won't solve it. Solve it. I'll just read, because you can just read. Why be scared of problems? You can try to read them and see if you get, because sometimes we can solve instantly, sometimes we may not. GCDs I cannot do. If given an array of length n whose elements are integers between 1 and m, all of them are between 1 and m, it seems we have multiple test cases. Some of m doesn't exist, some of n doesn't exist. She loves co-prime integers and wants to find four distinct integers p, q, or s. Four distinct we want, such that these two are co-prime and then these two are co-prime. That's it, is what we want. Seems so simple, but how can that be complicated? We have to choose 4 comma 9, 7 comma 15. See, seems simple, right? 4 comma 9 is co-prime and then 7 comma 15 is co-prime, so we are done. And here, if no such integer exists, output 0. If multiple solutions exist, output one of them. So what's the first question? When do they exist is the first question. When do we get to pairs of pairs? Sorry, a pair of pairs. P comma Q or comma S, such that we want a disjoint coprime pair. Seems so simple, but what would be the difficulty in this problem? Because the difficulty would be, finding one pair is obvious, is easy. For everything, if there is something coprime, you're good. But then the difficulty comes in finding some other coprime removing these two things, it seems. So So if you can find an a co-prime pair in O of n, you can solve this problem in O of n square is false, because you will find one pair, but you cannot guarantee that choosing that is optimal pairing, right? If you can, brute forcing in O of n power 4 is obvious. Anyone can do that. Choose two pairs. This is obvious. Maybe uh, if you can find a pair in O of 1, then you can do O of n cube, because brute force on p comma q, and then use O of n. If you can find a pair of co-prime numbers in O of n, you can do it in O of n cube. But how do we find? So we must use logic here, right? We must use logic. Co-primes are not too difficult, right? When or two things are co-prime. If some prime doesn't exist in both of them, then they are co-prime, right? So we must use logic. And the logic says, what is a co-prime? The primes in this should not be in there, right? So we have to find four integers such that they are like this and these are like that. So how difficult is it? Can we find at least one of the optimal pairing that will be in the end? Hello? Okay, your phone's broken. Bro, I am graduated and then I have no life now. So it doesn't help me if I grind too or not. But yeah, thanks. I'm retired now and then you're calling me grinder now. Because see, I'm not even practicing. I used to practice long back. So guys, let's try to think of this problem too. H we have read. We have to somehow use logic. Optimal way to choose four pairs if they exist. We should also guarantee if they don't exist. So we should also prove that if they don't exist. See? So it's a nice problem. I know it takes much more effort. Want the video to be also educational. So let me try E. Okay. Sorry. Who is that? Oscar me H. Uh, what can I comment? I don't know if I can use or not. That's why I'm not using it. I don't know what extent is allowed to use in contest. That's why I'm not opening the chat GPT thing, because I'm recording too, right? If I don't record, I wouldn't give a shit. I would have asked a chat GPT something. For E, let me also read E. Okay. You're given n for each index size such that I less than n, you can perform the following operation at most once. So for each index, we can do this just at most once, it seems. Okay, at most once. You guys can see if you do it on I, what's happening is they both are coming into that, right? That says something. Uh, you can choose indices and perform the operations in a sequential order. That's what it says, right? Yeah, so we can do this for each I, we can do once, and then we have to choose indices, and then we can do them in any sequence, it seems, because sequence matters, right? If ai plus 1 is changed before ai, then both of them will be affected, right? Given an array b of length n, determine if it's possible to transform a to b. Is this not a nice problem again? You have some operations. These are not reversible operations, right? Because we cannot do infinite number of times. We can only do once, but then we have to see the structure of the problem again here, right? What does it look like? We can only do once. Every operation can be done only once, and then we have to say if A can be transformed to B or not. If A can be transformed to B or not using such a thing. So all it demands is the structure of the operations, right? What's the structure? So we have, let's see, this subarray. Let's say from I to J, if we look at, let's say J came to, uh, see, let's, so one question, not one question, one observation, like, let's say if you put directed edges, okay, not even directed edges, let's say if you put like arrow marks between elements, that says this came before this, or that came before that, or such similar things, okay. Let's say we don't care about what came first and what came second, but let's just care about adjacent things, which one came before which one. If something has never occurred, that would be in the lost, okay. Let's say we just keep such arrows between just adjacent things. Does this fix B? Just fixing these things, would that fix B? Is a question. Because it seems, if if you look at, suppose this thing, okay, this says 4 came first, 4 came before 3. So what happens? First, this will get added to this. No, let's just call this as applying on. Okay. So let's just say, let me keep it like this. 3 came before. I'm not liking the arrow marks because it is coming here finally. When 3 comes before 4, this is coming here. So I want to keep arrow marks in a different way, if you guys see that. Okay, but let's just even not even look at this, okay. 5, let's say we have n. What happens is this comes to this, and then both of them go to here up to so on. It's forming just like that, right? So what I mean is, if before 3 goes, so for some I, before it goes to I minus 1, is it getting updated or not? That's what matters. So what I mean to say is, what all matters is if I came first of before I minus 1 or not, is what matters, how it affects this one, right? Because if this came before this, before you apply this thing, if this one came, then this has gone here. I'm complicating things. Maybe the structure would be much more simpler, probably. But yeah, we don't have an option. It's not bad to try to think on the structure. Finally, it will be simple. Yeah, that also seems fine, right? So AI can become BI if it gets AI. So that's what it is. So that's a good observation. That's the same observation. So one thing we can say is that's what I'm trying to say. So for some I, okay, before it goes to I minus one. So let's just look at I comma I comma I minus one. Okay, if I came before I minus one, then I won't be updated from here, right? Because I came before I minus one. I won't be updated from here because I cannot change now again. I came, so I has been changed. It cannot change again. Also, and it will be BI if there's a way. So let's try to see necessary conditions. What we are seeing here is necessary conditions. We are trying to think what are the necessary conditions if there is a way. It's all about finding necessary and sufficient conditions. Okay, we are trying to find necessary conditions here. And then I came before I minus 1, right? So now what happens when I minus 1 comes? If I minus 1 never came, then AI minus 1 equals to BI minus 1 must be the answer. Else, if I minus 1 came, then I minus 1 hasn't been updated till now. That means AI XOR BI minus 1 XOR BI equals to BI minus 1. So what is this thing say? If I came before I minus 1, we know everything that can be happening, almost everything that can be happening about AI minus 1. We know AI minus one's value itself. See, A minus 1 has two potential values. If it never changes, it should be the same. Else, it should be Bx or Bi minus 1. In both these cases, if it have actually came after this, if it has actually came after I, we can make it either this or this. So that's why they become necessary. They become sufficient. Here it becomes sufficient because if I became before I minus 1, I must be Bi. We cannot help that. Right? So it's sufficient now. It's sufficient. Why is it sufficient? If I came before I minus 1, then if this is equals to this, we will never apply I minus 1 at all. Okay. But we'll never apply I minus 1 at all. But if it actually has came, we will apply this too. And after these two things, what will happen? AI minus 1 becomes Bi minus 1. So AI minus 1 will become this thing after we apply these two things. Right. So how AI will become how I minus 1 will become Bi minus 1 strictly depends on AI minus 1 being this or AI minus 1 being this. That's it. And if it is happening for I and I minus 1, it's true for everything, right? It's actually being implies and implies. We need not look at every other order too, because it's difficult to use this much amount of logic even for me. But yeah, let's try to see, is this the only necessary conditions, because I'm trying to prove to, I'm not randomly submitting answers and then checking if they go correct or not right. So just looking at two things itself is being enough here somehow, because the thing is, whatever happens to this, that will become bi, right? Whatever has happened, whatever, many things came into that, but if there is an answer, we're trying to say necessary conditions. Necessary conditions means if there is an answer, what all will be true. If there is an answer, then what's true? Either ai minus 1 is bi minus 1, or ai minus 1 XOR bi is bi minus 1. Either of these two. These are necessary conditions. Now let's see if these are sufficient. Okay. That this is if I came before I minus 1, right? What if I minus 1 came before I? Let's try to just check that. Damn, it's not that simple now. If I minus 1 came before I, then I minus 1 must be equals to bi. So ai minus 1 only has three possibilities. It can either be matching to bi minus 1, or it can match to the final version of match using the final version of I, and then it becomes this, or it can use the initial version of that and then become that. So it can be either of these three things, right? Let's say if this is true itself, then if this is true itself, then what can we do? We can initially itself make that equal to bi minus 1. Sorry. So if this is true, we can initially itself do that. Else, we can, if this is true, we can never apply that at all. Okay. If this is true, we can somehow make this first and then solve this. See, our goal is to make a minus 1 bi minus 1. Okay. For that, necessary conditions or a minus 1 should be either this or this or this. So someone who just finds necessary conditions can probably code and then output the solution that if a minus 1 equals to either of these things, then true. For end, it's always true, because last one should be equal to the last one. For everything before that, someone just says these are necessary conditions. Finding necessary conditions is not difficult, right? Finding necessary conditions wouldn't be much difficult. See, I'm doing them case wise, if else case wise. If I came before I minus 1, if I minus 1 never came, if I minus 1 has came, means it got updated by the final version of bi, ai, or bi. If this came, someone can just say, assume without proving that these are the necessary conditions, and then they just code it and then output it. Now we have to verify if these are enough necessary conditions or not. So when this happens, what does that mean? Before applying this, we have to add that to here, and then we are good. But if this is also demanding this should have happened before, we could have always done that before, right? So let's say there is a chain that's demanding these things. We will all do those things before, and then those are done. If that chain is not there, we are even good. We can just wait for this side thing to be done and then apply it or never apply it. So if this is demanding, we have to just, before changing, before this, we have to. So I mean, if I minus 2 is demanding that previous value, you can just initially give that, and then it gets updated. If it has to go, it will first go and then it gets updated. I think this is sequential. It doesn't seem to have any issue, right? Let's say, let's say some indices demand the original value of the next thing. Let's look at the first such thing. That is the first thing that's demanding the original value of the next thing. Okay. So add that here. I mean, we can somehow prove that. But let's just uh, test sample at least. Okay. See, proving very clearly is much more difficult than just guessing solutions. Necessary conditions are enough to, but it's not too much difficult. It's simple only. I mean, we can not very clearly prove that, but we can see here very well. It's already batching, it's good. Let's come from that end. That end itself. Okay. While coming from that end, the only problem is we may use this original value before. That's the only problem. So all the things that are demanding original value, okay, let's say this is the only problem, right? Let's look at all the things that are demanding original value. So these things are demanding original value, these things are demanding original value, and then a gap came, and then these things are demanding original value. We can just do them from the beginning. First this gets its original value, and then this gets its original value, and then gets its original value, so on, done. All of them are done. Now what are left? The things that don't demand original value, right? And then this is already seen as implies and implies. So these are just enough conditions. Sorry. This is a necessary condition, and then from I equals to 0, I less than n minus 1, I plus plus, okay, and equals to f I equals to, or let me just put it as set. I don't know if set works like this or not. It's either b of I, or it's b of I XOR b of I plus 1, or it's b of I XOR a of I plus 1. I don't know if set works in this kind of format or not. I haven't proved this very clearly, but I'm taking light. I'm trying to take uh, some lenience, let's say, okay, because those necessary conditions seem sufficient. If do all the initial things, now everything demands only its final value, right? Now come from that corner. Everything demands its final value. If it's already done, ignore it. Now everything that's remaining only demands final value. So you can come from final values from this side, and then it's done. So damn, I have to sleep, I guess. Sorry for H, sorry for F, sorry for G. Maybe I'll read G and see how complex it is. See, for H, there is no other way. We must again use logic. We can't use some segmentary that gives us. We must use logic. We must use logic and then say that this is a way to find four pairs. We have to use logic that, I mean, we have some prime numbers, right? We have to use logic that somehow those prime numbers, no prime numbers fall between these two, and then no prime numbers fall between these two. We have to somehow find such two pairs. Fuck, do I have internet? See, it doesn't matter. I'm trying to consider order to prove things, okay? Hey, Ayush. See, you're worried about DSU on tree, Ayush. That's why you're not solving it. The why we use DSU is just see, you have to merge subtrees. You have to merge subtrees. It's not about DSU on tree. You can take it light. You can solve other problems. It doesn't affect you at all. Really, Ayush, you can solve other problems. Maybe I'll explain you sometime later. Okay. Really, it doesn't matter. I think just try to. It's just general DSU. Okay. The problem is merging two things. You have to find if there is a common element or not. If you use sets, you can do that. Yeah. I know it's an easy problem, but the effort I put into an easy problem or a difficult problem is same for me. It doesn't matter really because I don't guess much, right? Somehow it feels the same. But yeah, these things will get more with just the necessary conditions itself. It's becoming enough. Maybe some of them are not even necessary, but I think they must be necessary at times because this, if all are initially equal, we need not do anything. If take the original value, then this would be the better one. If taking the updated value, this would be the better one. Take initial value, this, or take updated value, or remain same. Remain same, take updated value, or take initial value. That's all it can do. That's the necessary one. And then that's being sufficient. Fuck such. I mean, we may not solve the problem, but we can guess the problem at least, right? Ayush, I was not considering order, I was just trying to explain it. Okay. So we have to try F because Sainath is asking it a lot. Where did I write that? Let's look at F. F still seems a tricky and interesting problem, right? We have to make them. Can we solve that? Can I solve that? How long would I take if I want to solve that? How can I solve that? Can I get something new? Probably not. I have to use something which I don't know, but I have to somehow use that. This seems perfect for first row. That must be done. But how complex will it get for other rows? And how can this be done in one go? So let's look at some path. Okay, let me use this thing. Let's look at some path. We have gone, we took down, we took some downs. Let's look at each row. We have one intersection, right? Here, intersection one, these two matches. There is only one element in this row, and then we have few elements in this row, and then we get here, right? Right. This is the structure of a path, right? And this is the structure of updates we do. Okay? This is the structure of the updates we do. What we can see from this and this is, I think we can see something. How can this structure change some path like this? So, if you see these things, okay, if you see these things, all of these are also zeros, right? All of these are also zeros. We need not do such complex things. It's probably an easier problem, but let's try to look at things in general. I will try to sleep if I can solve F because. So, all these ones or zeros, they don't change at all. So, how does it look if this path is on here? I think I should have used it reverse colors. Maybe let's say this is our path. If this path is on here, it can have greens, but then it can have reds. It can have greens, but then it can have reds. It is probably simple. We have to just think in some way because the pattern is almost same, right? I am overcomplicating things, but actually there are only two patterns. If you look at one row, because each column is either ci or ci XOR 1, right? So this makes it simple. This makes the array simple. I was unnecessarily thinking more, but this is an obvious fact we can try to use logically, right? Each column or same type of columns that exist initially, or they are flipped versions of themselves. So each column is the same pattern. That's an obvious thing we can observe. What is, how do we know? Let me check how many views I got so far. Bum, 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 bada, bum, bum, bum. Oh, damn, this one already got 2K views. And if I check the current one, can I check that? This has 288 views. 6 live viewers. 34 likes. No one disliked. Here's someone disliked. Probably me. Here we have much more dislikes. 3 dislikes. 1 dislike. We will solve this problem, people, because it seems not too difficult, right? We have two patterns for columns. So we have some two patterns per columns of this type or columns of this type. Let me check some messages. I know no one texts me, but just let me check them. Damn. I got a message to check on some friend. Fuck, I have to do that. It's weird though. Uh, Guys, can I solve this problem? Can we solve this problem? Sign help, bro. Sign help. Hi, bro. You good? Are you good? I'll call you in 2 minutes. I'll call you in 1 minute. I'm doing a shitty stream. I'll call you back. Be there by then. Bye. I don't know what happened to him. Uh, so we have to solve this problem somehow very quick now, because so now this pattern is same pattern. That's the step for us we have. It will always be the same pattern. Whatever you do, it will always be the same pattern, right? Really, is that true? It's probably true, right? Hello. What the fuck is a neat code roadmap? Sorry for talking like that. Okay. Sorry for saying it like that. It's just some. What is this? No, it's shitty thing. I thought it's a tool to write things well down, but then it's it's a website giving me shitty problems that I don't want to solve. Nah, nah. I take your sorry. I take my sorries back. Okay, I take my sorries back, guys. Let's think of this thing. Okay, even after the operations, it's always same two patterns repeating, right? If CI has, if this thing, if BI is some, if BI has some 0 1 0 1s 1 zeros, what we will finally have here is as columns, it's either BI or BI inverse. So this is how it finally looks, right? So if this is how it finally looks, okay, now our path, Sainath, I hope you're there. You're there, right? Water. Sainath, please, bro, I have some work to yeah. Now our dead pirate robots. Maybe I'll try it later because I have to sleep. You also should sleep. It's been 2 hours so far. We have to solve F and then we sleep. I can maybe solve it if I keep more time and somehow try it, because I'm not much scared. It uses logic. I'm scared. Maybe it's a much difficult problem because it had only 59, sorry, 100 solves, right? But if you want to test how much I can solve, I have solved some problems that had very few solves in past. So I'm not too scared. Maybe I can solve it if I try my best. So let's say we have some, let's say we have some. So what does this say? If we have some zeros, and then when we have this thing, what does this thing say? What does this thing say? I mean, uh, if you are going over blue, it doesn't say anything. Okay. Sorry. If you're going over blue, it doesn't. If you're going over blue, if you're going over blue, if you're going over blue, it doesn't say anything. But then if we take a green route from here to here, what does that say? We can keep going straight, is what it says. Because if this is green and this is zero and this is zero, that means all of them are zero. But how is that possible? They should be different, right? Because if this is zero, this is its complement, right? If this is zero, this is its complement, right? So what does that mean? If there is something like this, it can only be from blue things, right? That's what it means. Same type, it must be of same type. Finally, it must be of same time. Finally, all of them must be of same time. If you have advanced a bit here, let's say the first moment you cross from here to here, that says this type and this type must be same. The first moment you cross this to here says this zero says the both of them should be of same type, right? That's what simplifies the problem. That shitty fucking logic simplifies the problem. Now what does that say? The constraint. So it's as simple as this. Now it's as simple as this constraint. So first observation, this is the good observation that we want. Let me text my friend a bit. So this is what we want. There are only two patterns, and this pattern is complete complement of this pattern, because if one is if one is ci, do we have Synod? It needs work. It needs work. Dead pirate Roberts. See, F, I think. So just the fact that there are only two complementary patterns for each column, even after all the operations, there will only be two complementary patterns, says that the first moment you cross, you are reaching x comma y. Okay, means there are y columns. The first moment you cross this shit, the first moment you cross this shit, says something about that this pattern and this pattern should be the same, because there cannot be complement. So what does this say? What does this say? You want, finally you want from here to here, all these traverses that you do along y direction, all must be blue, is a necessary condition. All of them should be blue. So that's why it's too simple now. See, it's somehow simple. I cannot use intuition. I make statements, I use math, and then I solve problems. I am somehow bad. That's why I have some flaws, I guess. Sometimes I cannot, if by mistake on B, I make a wrong statement, problem B in division 1B, I cannot recover from that because I don't even see the problem. I only see what I wrote down, and then I do mathematically things. I don't know why I cannot use intuition, but I only try to use math, like trying to get some points and then try to get some other points or something like that. Because math is when you cannot think, you direct, you make results. Okay, this means this, and then this means this means this, because you cannot think on the whole thing. Uh, but problems are simple, so I think what I do is enough. So what does that say? All of these are same green, same pattern. All of them must be same pattern. So what does that mean? All of them are either all zeros or all ones is what it means. Okay, and the same thing means onto this too. All of them must be also of the same pattern from here to here, because you cross from here to here, you cross from here to here, it's symmetric. And that also means you're making all of this zero, all of this zero, that's shit, or all of this one and all of this one, that's shit. So we again have just two possibilities. So this has been simplified now. What is the minimum? This has been answered. This, even this is not needed. You make that whole box as zeros is the answer, it seems. That's so simple, right? To go from 1 comma 1 to x comma x, the what you must do is make all of them as zeros. All of them as zeros. That's the only way. You cannot do anything else because if you look at the structure, final structure, it's Ci or 1. So anytime you move like this, that says the pattern of both of them is same. Again, you must move from here to here. That says the pattern of them should be same. That means logically the pattern of everything from 1 comma 1 to y should be the same. So all of them are zeros, same pattern. So it's all zero zeros, 1 1. So only two possibilities are there. Even this gives out that solution, right? Two possibilities. For rows from 1 comma 1 to sorry for rows from 1 to x comma columns 1 to y, make all rows 0 comma calls 0, or make all rows 1 comma calls 1. Sainath, you might have expected more of this problem, right? Hello. Dread pirate, dread pirate, are you there? Sainath, you might have expected more of the problem, right? But see how simple this step is. It's making that whole thing as zero. That's the only thing we can do, it seems. See, it's shitty problem, right? You might have expected more of it. All problems are like that. We have to use logic. Yeah, you thought that, but then you have to believe in golden rules, Sainath. Do you see the difference? See, Dread Pirate Roberts, I will do part 6, part 7, part 8 of solving a problem in each rating. Then maybe you can see how I will solve a harder problem, right? Okay. If you're here, maybe if you come back, notice that. Even I thought for a moment, but then Sainath, if you believe in golden rules, you cannot see a simple proof for DP here, right? Because you have to do n square. You have to find that for everything, so that would not be that simple. See, this was my first question because I know we must simplify, because if you're solving it simply, we must simplify this thing first. So I have simplified that thing first. See how my structure is so perfect, because the structure comes from golden rules that solutions are simple, proofs are simple, implementations are simple. But this is a simple proof. If I can simplify this, I can give a simple proof that this is that, that is this, and then I can give that, right? So what does this mean? Make all rows zeros and all columns zeros. What does that mean? Minimum of C xc0, let's say xc1 plus xc1 plus you're making all of them, all of these ones as zeros plus, so you have to make all of yc1, all ones became 0, or xc0 plus yc0. This is the answer. And we know xc1 plus yc1 sign odds. We have to end the meet too. I hope I can do it by at least 2. Should I fall for that? Your explanation is really nice, and then say, yes, I will make it. I'm not sure. It's fine, bro. I keep getting minus 150s at times. Minus 30 should be fine. See this. How would I have felt here? And then here. Just imagine doing consistently well for 6 months and then fucking it up when you are here because you cannot handle fucking pressure. And then again fucking it up. And then again fucking it up when it's important. And then again fucking it up. But then somehow doing too good in the next contest. And then again maintaining. And then again fucking it up. And then again somehow again having hope that you can again come back. And then again fucking it up. Isn't this far worse than your graph or your struggle or whatever? And this I'm doing when I'm doing work full-time job. I even graduated. You can try parallelly because from here it won't be too difficult, I guess. Let's try this parallelly. I will go a bit slow, but let's try this parallelly, okay? Uh, Even I'm not getting anything, right? So let's try. I mean, it cannot get too much difficult from here. So we have to find this and this for all x comma y's, right? So let's do the obvious. Fix x, okay. Sign you can follow me. It's fine because there is not complex things here, right? Fix x, then that fixes xc1 and also fixes. So if you fix x, that fixes xc1 and xc0. But then you need this summation over all all y's. But then yc1 and yc0, that pattern of yc1 and yc0, that is fixed. That is fixed for all rows. So you have a pattern on yc1 and yc0. But then you change you change them somehow. Fuck. And then when you add this value, it should be simpler. I'm thinking more, but it should finally come across as simple. You can say some things. All of this will change by plus 1 or minus 1 as we go from y to y plus 1. Let's look at some x. If we go from y to y plus 1, they change by plus 1 or minus 1. Either yc1 increases or yc0 increases. That keeps happening. So can we fix x and then count this summation over all y's is first one. We want this summation very quickly now because we have fixed x. That's one obvious thing we can do, right? Fix x and then try to see for this value and this value, can you get this summation over all y very quickly or not? But what other things can we do? Can we try to see how xc1 plus yc1 changes over all? If you are trying to see yc1 plus xc1, how this value changes for all cells, let's try to see this value, how it changes, okay? Whenever if this is 1, for all of them it is plus 1. And then it stays 0. But then when we come down again, again from all of them it's plus 1. That's how it changes, right? So if you look at how does this change, how does this change? Okay, let's look at how does this change. It doesn't change much. If you see, it doesn't change much. If you try to see how does this change, okay? Let's look at them as blocks, okay? For simplification, like for geometry from above, if you look at from above, let's look at them as blocks. Let's look at this value xc1 plus yc1, okay? Let's say this is our grid and let's look at that value. Initial row will have some values, right? Initial row will have some values. Whenever 1 comes here, that value increases. We got another block. But whenever that value stays 0 for so many number of times, let's keep that value as just like this. That value is not changing at all. But even if it changes, also we have just few more blocks, right? It will be the same at multiple levels, like same number. So now we have these blocks, okay, of different values. So let's say for every one we have divided once, but then if I again do the same over this side, it will become too many blocks. I thought of limiting number of blocks, but then that doesn't happen. I mean, there should be some simple way. I cannot waste this much time. What else can we do? We have to fix x and then we have to just solve the problem, right? Should be simple. Let me think at least. Bro, I have to sleep, bro. Is anyone there? Dread Pirate Roberts. I will try to do higher rating streams in my next contest. Okay, not next contest, in next stream. Today I planned part 5, part 6, part 7, part 8 of solving each rating in a problem. Try to attend them. Okay, maybe then we can try to solve higher rated problems together. So now this must be solved. We came till here. Can't we evaluate this thing? Again, I don't know why I got that intuition to look at them like blocks. Okay, let's try to look at them like blocks again. So let's say this is our block, initial one of 1 comma 1. Let's say this is our first one, and then this is our first one on this side. Till this first one we have all of them as zeros, right? And then what does this one do? For all of this thing it will increase that value by plus 1. What does this one do? For all of this thing it will increase that value by plus 1, right? And count of ones and count of twos. So we're going to have how many different values? So just let's look at ones. Okay, let's just look at ones. Let's just look at these ones and then these ones. Okay, at least theoretically, because simple implementations can become simpler later. But solutions wise, just look at ones. Okay, we are worried about count ones, right? Let's look at ones. This will have zero, right? And then this block and this block, which are occurring diagonally, they will have one and one. And then this block and this block and this block will have 1 plus 1 plus 1 2. See how it makes sense. Only ones affect our count of ones, right? So let's look at these ones here and these ones here. Now what, how the blocks will be divided? So these blocks, I mean these are like, at least this gives us some structure, but these blocks, these three are together. We cannot just separate them as blocks. It's still too many blocks, right? It's not less number of blocks. It's like n square blocks. It's like number of c1s here times number of c1s here number of blocks. And I don't think it's some root n logic, because that's too much for this problem with that many solves. Mm, but at least logically it says we only have less values, less number of different values. At least we only have less number of different values. What do I mean by less number of different values? I don't know. Fuck, I'm tired. Can we solve this? Stream's becoming lengthy. Guys, think we have to solve it quick. In O of one, we have to just solve this thing. So let's fix x itself, okay? Not try to think much, because that would be the way. And then we have two different values, and then we have a structure for yc1 and yc0, okay? We have a structure for yc1 and yc0. I mean, geometrically we can solve it in some way, because if you logically go over uh, these lines and then try to find what would be the intersection of, this is too much, the other rectangles. This is definitely not the answer. I'm just telling. At some point, the other rectangles will cross these rectangles, right? Till then, we have to take the blues count. When the other rectangles, okay, after that, we have to take the blues count. Otherwise, for other things, we have to take the reds count. But then we again have to get the reds summation. Yeah, that's more complex, but yeah, probably it's fixing, after fixing xe1 and xe0, we must be able to find this thing. That's the way. There cannot be any other way, right? So let's just have two arrays, okay, which is xc1 plus yc1, and the other one is xc0 plus yc0. Let's have those two arrays, okay. So we have these two arrays with some values, and then either one of them will increase. That's one thing. Both start somewhere. Either one of them will increase. Either one of them will increase. Right? It can increase and then it can stop and then it can increase. It can increase and then it can increase. Either one of them will increase. And then we'll be having minimums. Right? So it's like, if you see this array, it's like always we have one thing, and then the next thing became better, and then okay, let's try to see this. Okay, let's try to see this. So let's look at one thing here. Let's look at one y thing here. Okay, let's look at one y. That's what we're trying to see. Let's look at one x. That's what we're trying to see. Mm, it's not that difficult somehow, because if xc1 and xc0, if you fix, okay, if you fix xc1 and xc0, we want xc1 plus yc1 less than or equals to xc0 plus yc0, these indices. And then we want x, see, brute force only it is xc1 plus I, me thinking is unnecessary, anyway, always these indices of y, we want these things, right? And what are these indices of y? Minus xc0 less than or equals to yc0 minus yc1, right? And then what are these indices of y? xc1 minus yc0 greater than. So it's again not thinking and directly applying things. So if we have all these indices, and if we have all these indices, we have to sum this. We have to sum this value. xc1 is fixed, right? We have to get sum of yc1s for all the y indices that have the value greater than this value. So if you have this, if you have sorted these indices in terms of these things, okay, if you have sorted these indices of y in terms of this thing, you guys should clap for me for just rearranging terms and then making things simpler. See, it's just asking for what to be done. Because I was thinking unnecessarily, but then we must find the indices where this is smaller. We must we must find the indices where this is smaller. Otherwise, we cannot do anything, right? We must find that sum after fixing x. Now look at those things because we must do that. And we must look at what we need, this shit being less than or equals to this, or this shit being greater than this. So that just says sorting y indices in terms of yc0 minus yc1, just rearranging things. Let's say if you have sorted y indices in terms of this value, okay, now what's happening? You want sum of xc1 plus yc1 of these starting indices, and then you want xc0 plus yc0 of these indices. So you have the y indices, you want some array sum of these indices, and then you want some array sum of these indices, because yc1 you want yc1 sum of these indices because sc1 is fixed, you want yc0 of these indices. How difficult can this be? Because once you increase x, what will change? These values will change either by plus 1 or by minus 1. They don't change much, right? If they don't change much, what about these values? They also will either change by plus 1 or minus 1. But once you sort them, they can be same for most of the times. But still it's simple. Maybe you can do binary search, or you can somehow add some bias, and then you can directly know the value. You can do anything. It's just prefix sums now. Prefix sum of yc1 of these indices, prefix sum of yc0 of these indices. Sort them, prefix sum of these indices, prefix sum of these indices, and then done. Uh, who is here? Sinad. Is this simple? I think he left. So we have to implement this thing now, right? I want to make things positive, okay? I want to make things positive. So let's add plus n here. And then let's add plus n here. So we'll sort this shit. It can at max go to 2n. Right. I'll sort indices using this shit in a 2n length array. And for each of these index, I will have either yc1 or yc0. Okay. And then I will have prefix sums of those two things too. Okay. And then I need prefix sum of yc1 here, and then prefix sum of yc0 based on this value, which is also positive. People here. Seems Sainad is here. So does this make sense, Sainad? Using prefix sums, sorting things. So first what I will maintain is, I will maintain yc1 prefix sum and yc0 prefix sum for in this ordering, because if I do that fix, we already fixed x. So for y, we want to, if we have them in this ordering of this particular value, if you have them in this ordering of this particular value, then it's always taking this sum or this sum. Do you see how my implementations are so simple and cool? I even made such a thing to make the arrays positive. So now what will I do? I'll code it out. So when I say implementations are simple, people think I'm again bullshitting, right? But not, I'm not bullshitting. See how I made a simple implementation for this. But I should be quicker, I should not be this slow, right? It's like art if you people realize. So now we have one is C XC 0. Sorry, YC 0 comma YC 1. Is it 2n? The max value is 2n, right? Because yeah, max value is 2n. Okay. This is too much. Why can't I just use this? Why can't I just use that? I mean, I'm definitely taking much more time than what someone took if they do it in a contest, but you guys have to see streams are a bit more difficult than contests because I can most of the time solve many problems in Div 3 if I give them. Unless I fuck up contests like I do in general. So now what will I do? I want to maintain YC1 and YC0 at these indices. Okay. At these indices I want to maintain. Right. So what will I do? I'll go over all Y's. I will go over all Y's and what will I do? This is 0. Right. Let me also maintain count of C0 and C1. We see this? It's C0 minus C1 plus N. This seems complex, but I'll do this because I can do that. Okay. So we are adding a 1 there to YC1 because there is a 1 over here. Right. There is a 0 over here. We just want here count of ones and count of zeros among this sorted answers. So I'm just trying to add a 1 whenever there is a 1, add a 0 whenever there is a 0 among those things. Okay. I mean, this seems like a complicated thing that I'm doing. There can be simpler solutions, but why? It's not that of a difficult idea, right? It's not that of a difficult idea. And then we are done. We just have to do prefix sums now. Now what will I do? These are xc zeros and xc ones right now. So now we have our first xc zeros and xc ones of first row. So now we have our value xc0 minus xc1 plus n. So for things less than or equals to this shit, what should we do? We have to take this one because that's what is minimum. So we have to take for less than or equals to this things. Sorry, for yeah, for y's which are less, which are greater than or okay, we have less than here. Okay, let me put this here. Let me put this here. Doesn't change. For our values less than or equals to this, we have to take xc0 plus yc0. Okay. For values less than or equals to this, we have to take xc0 plus yc0. It's getting a bit complicated because let's just say let's call this j, right? For this we need xc0 plus, for y's less than or equals to that we need xc0 plus yc0. We can directly access sum of yc0 using prefix array. For all these indices we get that, but how to get xc0? To get xc0 we need number of indices, but I'm not maintaining number of indices, I'm maintaining these two things, right? So what I have to do is I need number of indices too. Number of indices equals to yc0 plus of j plus yc1 of j. Just agree to this because number of indices is just this. So answer plus equals to xc0 times number of indices. Number of indices is yc0 of j plus yc1 of j. Okay, plus yc0, which is just prefix sum. One minute. I should add yc0 over all those things. Is that what it is? Damn, I should take double prefix sums. So C0. So C1. Okay. Let's just also maintain count. It got a bit complicated. I thought it's simple, but then it got a bit complicated. But I am fine with this of this level of complexity. If we get wrong answer, just leave it here. If we don't get wrong answer, so this shit is to get this number of indices. Okay, this will have number of indices and this will have yc0 itself, and then we want sum of yc0s. That's what we want, right? We want to find sum of yc0s. Maybe I got carried away because I want sum of yc0s, which I will use prefix array. For some I will use this indices array. Okay, it's not too complex. I am making it sound complex, but it's not complex. So now if we see these things a bit more clear, so now this is simple. What it is, yc0 of j. Because yc0 is actually sum of c zeros. Because it's prefix yc0. And what is this? I'll just use in count of j. Count of j will give me number of things came so far. X0 is fixed. And then this will have sum of yc zeros. Okay. Plus xc0, xc1 times n minus count of 0. That's obvious because the other indices are n minus count of 0. But what about the other ones? yc1 of j minus yc1 of j minus 1. And this will at least be 0 minus n. It can go 0. So let me add j equals to 0 means 0, otherwise subtract it. So this will have the prefix sum of the other things, the greater than things, right? Fuck. I cannot keep having these things. Why doesn't it agree? Why can't I just test it simply? Guys, if you guys are really scared of my implementations or my level of logic, I want to tell you people that I can use much more logic than an average 2300 people because this is not a flex because I've solved much more harder problems and I can do much more bigger implementations. That's why. So don't think to be at my level of rating, you need so much like I can do. Okay. You guys will see that soon. I will increase my rating to somehow near 24 plus at least, 25 plus or 26 around that. At least I think I have to do that because I cannot show all these things that I do so easily and then I mean I get wrong answers. That's the reason why I'm still here. Until J you have taken here. So greater than J things should be taken here, right? Eyes are fucking hurting. you're adding an index I of size C0 to that value. So we have different indices with different C0 minus C1 values. For all those things, we have those values. When we sum of that like this, we have the prefix array that had sum of all Y0 sums, C0 sums. So it's all good, it's all right. I can't think solution can have some wrong answers because this is obvious. This is even true in the original case because we have that's this is true. Let's just wait. So let's just print the answer. Let's just take this simple thing, okay? We have 1100. For row 0, my answer is telling that it's 2. Is it 2 for this down? Is the answer 2? Is that people? Everyone left. Wait, is that Sainad? I want him to see if this got accepted. So, first discussion below. One operation, one operation. So, first answer is 2. Row answer is 2. That's fine. And then the next one's answer is how the fuck is it 4? Do we need 4 flips to go from there to there? One plus 2. So here, what is this? Why did this become 4 is the question, right? So this index had, see, indices has YC0 as, just let me write them. YC0 as 0, YC0 as 1, YC0 as 2, YC ones or zeros. So they will go to, these are YC zeros, also YC zeros minus YC ones. Okay, they both are same because YC ones are not there at all. This is a simple case for us to verify our solution at least. So if you look at XC ones minus XC zeros, this is 0, right? If X is 0 minus XC1 is 0, and if it is greater than this, what all should we be doing is indices of Y. Here, XC1 plus YC1 is minimum. There are no lesser indices. Everything is greater indices. And for the greater indices, we should be taking xc1 plus yc1. And xc1 is making this as xc1 is 2. And xc1 is, this doesn't make sense. I'm just trying to verify the test case. YC0 minus YC1. I mean, this is a complex way to go through, and then again, verifying is also a bit tough. Not too tough. YC0 minus YC1. What is this value for this index and this index in the 2 cross 2 grid? It's always, for this it's 1 and this is 2. So YC0 and YC0 are 1 comma 2. So that makes sense because 2 plus 0. So this thing, I'm thinking, I'm telling that taking xc1 plus yc1 is minimum. So I'm doing 2 plus 2. But then for this, they are telling just flipping this is enough, right? They're telling yc0, yc1 is better. They're telling making everything 1 is better is what they're telling. That means yc1 is better. That means yc1 means this is minimum. Because xc0 is 0, yc0 is 1. So this is minimum. xc0 is 0, yc0 is 1. So that is minimum than 2 plus 0, right? So why the fuck did I think something is wrong? Because if this is minimum, this should be happening. And xc1 minus, okay, this is n plus 2. So this is 2. So this is 2. So this should be happening. Hey, see, this is xc1 minus xc0. xc1 minus xc0. People, why are you not helping me? You guys can see why I don't become a grandmaster, right? You guys can obviously see me. How long did I struggle just after making this mistake? Yeah, still we have more mistakes, but that is an obvious mistake. As long as you are less than or this value, you have xc0 plus yc0 as minimum. So as long as you are less than or equals to that value, you have xc0. Sum of yc0 we get from this. Guys, I should sleep. What are the answer for second test case? Did they give them? Did they give them? No, they haven't given. So, what are the second test case answers for rows x0? This is already 0. So, this is already 0. So, this is one flip. So, if I run that one test case, that one is right. And then this 2, is that right? Make first row is 0, second row is 1. So, for this, first y is 0. So, just changing second row is enough. So, that is 1. But for the next thing, what's the array here? Initial array? Uh, 0 cross 0 is 0. 0 cross 1 is 1. 0, 1 cross 0 is 1. 0 cross 1 is 0. So this is the initial array, right? So for this, we need not do anything 0. For this, we can just flip this 1. So that's right. So if you look at this, for this, we can just flip this. So it's 1 plus, for this, we must flip two things because we must, if you are making it 0, then we must flip x is 0 plus y is 0. So there is something wrong in here, right? So let me look at in terms of, so it should be correct. If I be careful, it would be right. Guys, I can't be doing you people sleep, right? Sleep, leave the stream, watch it tomorrow. Is there a bug? Can anyone see a bug? Implementation is simple, but I don't get it. Uh, It should have been right on first attempt, right? Let me see if there is any one small bug. This value cannot go negative because we have plus n for the only negative, and then it cannot go till 2n plus 1 because this can at max be n, and then this is negative. Wait, if I have just fucked up one number also it would have been gone, right? So let me again verify the formula once. X is 0, making all ones as zeros, making all zeros as ones, right? And then less than 0, which would make yc1 come this side, xc0 come that side, and then I've just added plus n on both sides. We have yc0 minus xc1, but then we have xc1 minus yc0. And as long as this shit is less, we have xc0 should come less than or equals to. So as long as you're less than or equals to xc0 should come. And then x yc0. As long as this happens, then yc1 minus yc. What could have been wrong? So why am I getting this as 2 is our question, right? So what is j? What should be j? J should be 1 minus 1. J should be 0. So let me see the values of yc zeros, comma yc zeros, yc1. Because if you can debug this one test case, we are done, right? So yc zeros minus yc ones is, initially it is 1 because we have one count of 0, but finally it became 0. So these are the values, right? But if you see xc1 minus xc0, what is that value for this shit? For this array, x is, for the second row, xc0 minus xc1 is 0, right? So for the things less than or equals to 0, I'm itching a lot. For these things, we want, so for this thing, we want to take xc0 plus yc0, which would be 1 plus 1, 2. That should be 2, right? And then for this, it should be xc1 times 1 times 1 plus yc1 minus, for this index, number of 1 should be 0. So this should be 1. This should have been 1, and then that should have been 3. J is 0 here. Fuck. So it should have been correct. It should have been correct. So let me just output these two things too. This is 1. This is 1. How can that be 1? That should be 2, right? That should have been 2. And then this would have been 3. Because that should have been 2 because x is 0 itself is 1. And then count of j would have been 1 because there is a 0. And then yc 0 would have been, for this thing yc 0 is 1, right? So it's like changing this 0 to 1 and then this 0 to 1. Changing everything to 1. So that is 2. So let me just verify those two values and then we'll be good. Maybe there is a bug that I mean I'm sleepy too, right? Like I cannot say these many excuses. Guys, this will give us our bug. This will give us our bug. 1 1. How is yc 0 0? How is yc 0 0? Because for this j is n, right? And then we have 1, right? We should have added that 1, right? I should be adding it every time. No. 1 minute. Yeah, I should be adding it for all indices. I should be adding it for all indices. I mean, it's complex, I guess. I should be adding it for all indices. What the fuck can I do? Explaining in parallel is not that easy, right? See, I do this kind of things to unnecessarily increase complexity of logic. I don't know if there is there can be, there should be simpler solutions. I mean, not simpler, idea should be the same, but maybe implementation could have been a bit more brute force than going over this. I wanted to show how we can use no sorting. There is no sorting I have done. I didn't use map. I didn't use anything. I just used prefix sum. I didn't even use map. The complexity is O of n and not O of n log n. They haven't used segmentary for sure. What the fuck is not loading now? I can finally sleep, get some sleep. You guys there? Bro, it's not loading. It's not loading. Wait, is it maintenance issue? Is it maintenance issue? No, it's not a maintenance issue. It's likely my internet issue. What was the fucking error for each index I know I want is yc1 value and yc0 value? Probably because I am bored. See, simple and nice solution that I struggle a lot, but yeah, simple and nice solution, right? Simple and nice solution. No array, O of n solution. Let's take some random solution and see if it is O of n. Okay. Let's take some random f. I hope it's not too small. See, there is sorting. We are not doing any sorting. There are prefix sums. I think anyone must do the same thing. There are not much different things we can do here. Probably. See, a1 times this, x times that, sum of y minus. It's the same thing. I think there is no other option. Probably it's too direct. I just like it my implementation of mapping that to 0 to 2n. That's unnecessary, but I just like that. I think. Yeah, okay then, guys. Good night. I'm ending the stream. I can't do it anymore. Yep, ending it. Thanks.